From small, we've learned that the Earth revolves around the Sun, and that the Sun seemed to stand still. But it's not that simple. Earth's motion in the galaxy, much more complicated. While orbiting the Sun, the Earth is moving at speed, up to hundreds of kilometers per second. And even scientists think that these movements can make us touch with more cosmic rays, leading to gene mutations, and even cause large-scale extinction events. This way of moving can also affect the environment, leading to the possibility of a new ice age. To better understand, imagine you're sitting on an airplane. Fly at a steady speed and altitude. You won't feel the speed or the altitude of the plane, but the people standing on the ground, you'll see the plane moving very clearly. This phenomenon is, Galileo was mentioned for the first time in his book, Talk About Two World Systems, published 1632. Today, we call this phenomenon the principle of relativity, Galileo or Galileo invariant. This tells us that motion without an absolute frame of reference and multiple frames of reference can be reasonable depending on the circumstances. So what does this have to do with the movement of the Earth and the entire solar system? First, we need to identify the point of view, as seen from inside the solar system. As we often know, the planets revolve around the Sun, but from a broader perspective, we will see that the solar system is moving in a spiral in the vast space of the galaxy. We know that orbit, the Earth is not a perfect circle. It's an ellipse with the Sun near the center, which means that there are points on the fund. The Earth is closer to the Sun. It's called the Japanese approach, and the farthest point is called the aphelion. We often describe the solar system with the Sun in a central location, and the planets around it. However, this description is not entirely accurate. The planets don't just go around the Sun. It's dragging the Sun, make it move a little bit. For example, gas giants like Jupiter and Saturn has a very strong gravitational effect on the Sun, and the Earth when Jupiter and Saturn, sometimes in line with each other, they can cause small changes in shape and the Earth's orbital direction. These impacts, it's called perturbation of the outer planets. It greatly affects all the heavens body in the solar system. Over time, these small changes can accumulate and lead to long-term climate change and the environment. It's called the Milankovitch cycle. In the 20s of the 20th century, Milankovitch proposed an astronomical theory of the ages, Ice Age in the 4th century, based on the Ba elements of Earth's orbit, eccentricity, tilt of shooting and precession, cycle, changes in the tilt of the Earth's axis during the cycle. Milankovitch lasted about 41.000 years, and its angle of inclination relative to the plane, Earth orbit, changes from 22 degrees a year to 24 degrees a year. As the axial tilt increases, our seasons have become more severe, because every crane gets a lot of solar radiation, more in the summer, less in the winter. Large inclination angle is also favorable for the melt stages. Ice. These impacts are the highest globally. Fluctuations in total radiation. The Sun in high latitude areas is much larger than with areas near the equator. Now the Earth's axis is tilted about 23 degrees for only half the maximum inclination value. In a 41.000 year cycle, this angle is slowly dropping. The last time it reached its maximum inclination about 10.700 years ago. And after about 9.800 years, it's going to have a minimum inclination. When the angle of inclination decreases, our seasons are getting milder, with the winter getting warmer, and the summers getting cooler. Over time, snow and ice in the mountains. The altitude gradually accumulates into large ice sheets. As these icebergs grow, they reflect more of the Sun's energy back to space, contributes to extra cooling. General change in the tilt of the Earth's axis will affect the amount of solar radiation to different parts of the Earth's surface. It affects the duration and intensity of the years. Ice. Next, let's take a look how the Earth moves in the world. The galaxy is a huge and complex system, including countless south stars, gas and dust, with a diameter greater than 100.000 light years. One interesting thing is that the galaxy rotates like a giant millstone, with the arms, spin, pull, follow everything inside. The Earth is in one arm of the galaxy. It's about 25.000 light years from the center. In the solar system, we just need to look at the impact of gravity from some celestial bodies, where the Sun is the main source of gravity, the opposite of gravity in the galaxy. It's not made by a dominant object. It's the result of interaction between all the celestial bodies. This makes tracking the motions of different parts of the galaxy become difficult, but it's also very interesting to help us better understand its complex structure. It's like the Earth goes around the Sun, The Sun also orbits the center of the galaxy with a speed of about 230 kilometers per second, and to complete a cycle, it takes about 230.000.005. This space journey takes the Sun and the Earth across different parts of the galaxy to help us interact with the space environment. Different is more interesting. Places near the center of the galaxy, it's got more mass and stronger gravity. Therefore, stars in the center move faster compared to the stars outside. This difference in speed is like the planets near the Sun. They're moving faster than planets far from the Sun. To determine the speed of the Sun compared to the center of the galaxy, we need to find new stars because they're still in their original orbit. And then by calculating moving speed, the average of these stars compared to us, we can deduce that the Sun is drifting forward at a speed of about 5 kilometers per second. It's approaching the center of the galaxy at about 8 kilometers per second. And it's leaving the galactic plane at about 7 kilometers per second. Even though these speeds don't sound like much, but they have a huge impact on the orbit of the Sun and the solar system in the galaxy. The Sun's orbit around the center of the galaxy, it's not a perfect circle. It's a slightly elliptical line that oscillates up and down. Complete one rotation about every 60.000.005. This transmission is affected by the gravitational pull from other stars, clouds of gas and dark matter in the galaxy. Currently, we're lying on the plane of the galaxy, some 15 light from the center. Although it's difficult to pinpoint exactly location of the center, but because there's more material at the bottom than at the top. Gravity from the galaxy has slowed down our upward movement. After millions of years, we're going to stop at a distance of 300 years, the light above the galactic plane, and start moving down. This phenomenon of longitudinal oscillation, it's not just a strange thing that some astronomers even support. Shiva theory, given that this phenomenon may be related to events, great extinction on Earth, because the density of SAO in the center of the galaxy is higher. The radiation is also stronger. Put our solar system in a bad situation, more dangerous. The motion of the arms in the galaxy has not been fully studied, but there are theories assume that many factors can affect them. One of those factors, it's the gravitational pull from galaxies other in our galaxy cluster. Another factor is the existence of density waves. These waves land radiating on the plane. Flat galaxy, it's like the ripples on the pond. They can propel stars and gases in or out of the arms, impact on the environment and living conditions on Earth. As we go through these areas, as the Earth moves through these regions, has a higher density, there may be more cosmic rays and higher energy particles to the Earth's surface. This could affect the climate, chemistry in the atmosphere, and even the evolution of life on Earth. Of course, the Sun doesn't stand still. It's moving through the galaxy. Take the Earth and other planets. The movement of stars can be described through their own movement. It means movement. You can see the stars in the sky. Over time, this is due to the movement of stars compared to the Sun. Normally, they measure this motion in terms of the strain. Every year, that's the angle at which the star moves in the sky. For 1 year, the concept of individual motion, to help astronomers track the movement of SAO stars over time, and location research, as well as how they change relative to each other. This is very important, because it helps us understand the structure better, and the dynamics of the galaxy. Next, we're going to look at the motion of the Earth relative to the nearest stars as the Earth orbits the Sun. The position of the nearest SAO stars in the night sky, it will change a little over time. This phenomenon is called parallax. That's because at different times, in 5 places the Earth's position in orbit changes, which leads us to see where the stars are. There is almost movement. Each SAO has a different level of parallax. It depends on its distance from the Earth. The closer the SAO, the bigger the market. The farther the star, the smaller the market. Astronomers use parallax levels. This is to determine the distance to nearby stars. It's very important to understand the size and structure of galaxies. It's not just wrong how we feel about the night sky, still affected by the individual motions of nearby SAO stars. In a few years or 15, position of SAO stars due to their own motion in space will change dramatically. What this means is that these constellations that we see today, it will be different in the future and it will be different in the past. Especially SAO stars have large individual motions. It means moving fast. There will be a more pronounced change of position. We're currently investigating the way the solar system moves in galaxy. There's an amazing discovery, but there's still a question. How we're moving through the universe. In fact, our galaxy is not alone. On this journey, the galaxy is constantly being pulled by the surrounding gravitational fields from different galaxies and masses. We're currently moving at 600 kilometers per second towards the Andromeda galaxy. But that's not all. Our galaxy is part of one big family. It's called a local group of galaxies. The group consists of more than 54 galaxies. That includes our neighbors, Andromeda galaxy, local group of galaxies, along with other galaxy clusters, is moving towards an area of super high density. It's a mystery called the giant gravity attraction source giant. It's about 150.000.005 light away, with gravity so strong that can affect the motion of galaxies within hundreds of millions of light years. So the local group of galaxies is being pulled towards attraction source giant at a speed of about 600 kilometers per second. However, it's not the last movement of the Earth. In the universe, the whole universe is expanding. That means that all galaxies are moving away from each other. This expansion is not due to galaxies moving in space, but space itself is expanding. The end result is the distance between galaxies increasing over time. Even though there's all this movement, we can still use the cosmic background V radiation, CMB, to determine our speed compared to other parts of the universe. This radiation is the excess heat from the Big Bang, land spread throughout the universe. It's almost uniform in every direction. By measuring small variations in this radiation, the scientists have determined that Earth and the entire solar system, it's moving in space with a speed of about 368 kilometers per second. Compared to the cosmic background V radiation, now the Earth is not standing still. It was no longer a surprise. It's just a small part, but important, in a complex system of celestial motion. It's about the movement of the sun and the planets in the prize. The galaxy is over. Thank you for your interest and follow up.